So on your chart, your numbers should be similar-ish. You should have a fairly large positive number, a very large negative number, and then a smaller negative number. Do I have a volunteer to explain the pattern that we saw from 1960 to 1977? Why did that change happen? Go ahead.
The disease was inoculated, and that led to a surge in population, as now they could reproduce without the limitation of the disease.
Perfect. So disease was wiped out. We started to vaccinate against it. The population started rebounding, going back up to its normal population after the disease. Okay, 1977 and 1978. Why do we see a decrease in population? Ooh. Want to go again? Go ahead.
The surge in population causes the other limiting factor of the amount of food availability to be hit. So then there's not enough food to support the entire population, so the population automatically declines.
Perfect. Whoever has music, turn it off. I can hear it from up here. That's an issue. That's exactly right. So once our disease population started to increase yet again, there's a limiting factor of food. Only so many wildebeest can be in the area at once. Therefore, the population will decrease because there's not enough food. And we saw that in our little walkthrough that we did. Then lastly, 1978 to 2004. Why do we have a slight decrease? The book didn't tell you. We had that slight decrease because it's just a part of life. The population, we can say, stayed pretty stable, around the same. 2,000 wildebeest compared to 1,500,000 wildebeest is nothing. There could have been more predation that year, throughout those years, sorry. There could have been the poachers. There could have been just more wildebeest dying just because. There could have been any number of factors, but we can say that it really wasn't significant, the amount of wildebeest that died. So using this information, you then answer some questions on 78 and 79. 78, question number 6 says, what do the rates of change tell you about the effects of limiting factors on wildebeest population during these 3 different time periods? Does anyone want to answer that for us? What does the rate of change tell us about limiting factors? Awesome. I heard someone say the rate of change shows us that the limiting factors don't let the population grow to infinity. Our limiting factors cap off our population. It just can't keep growing and growing and growing. That's not realistic. This is real life. Eventually, population will have to stabilize. Question 7, in 1993, a severe drought occurred in the Serengeti. What happened to the population? Show me with your fingers. What happened to the population? Yes, it went down. Population went down, it decreased. From 1993 to 1994, your evidence from the graph should be, in 1993, the population went from 1,200,000, and it dropped in 1994 to 900,000. So, based on the graph and knowing that the population decreased, should our rate of change be positive or negative? Negative. Our rate of change should be negative. And if you ended up doing the math, you would see, yes, our rate of change is in fact negative. So negative rate of change, loss of population. Positive rate of change, increase in population. A 0 would mean no change in population. So then question C says that wildebeest population data is not available from 1995 to 1998. Explain evidence from the graph about if and when the drought ended. A lot of you had great questions. So after 1994, did the population keep decreasing and then we saw that increase in 1999, or did it just increase steadily the entire time And quite honestly, it doesn't really matter what happened between 1995 and 1998. If you look on the graph, 1999 shows that there was an increase. So that gap of time that we don't know doesn't really matter. Because we had that increase, we can say that the drought ended. The population rebounded back to around its normal. We can tell that because the normal is around 1,300,000. And lastly, question number 8 said, if conditions in the Serengeti remain relatively constant, what do you predict would happen to the wildebeest population in the next 20 years? I want you to talk to someone next to you about your prediction, then we'll share as a class.
It would change severely in let's say the drought, or they use fertilizer species.
Okay, what do we expect to see? What's our prediction? Go ahead, and then we'll come over.
It should remain relatively the same population. It might increase, it might decrease, but overall, it's not going to change severely unless there's a major event that occurs that modifies the limiting factor severely.
Awesome. Did you say about the same thing?
I think it's going to be constant, but there's probably going to be another drought.
Probably another drought. Yep. So your population will remain constant unless something with those limiting factors change. Because we have limiting factors, I want you to flip to the graph because we are going to label this. No, we're not. You'll do it tomorrow. How is class already done? That's crazy. Well, I'm going to keep talking to my iPad. Because we have limiting factors, we have this thing called a carrying capacity. And in our graph, carrying capacity was around 1,250,000 wildebeest. So therefore, we can say our limiting factors set our carrying capacity. Tomorrow you'll be using these ideas of limiting factors and carrying capacity to start our first assessment of the year. So come prepared. If you have questions about limiting factors or carrying capacity, please email me.